Hi class, we're going to learn a little bit today about quadrilaterals. Maybe you tuned in to the lesson last week. If you did, great. You can watch again today and get a little bit of a refresher. Maybe you didn't watch it or didn't attend that lesson. That's totally fine too. We're going to kind of repeat what we did last week in that lesson. So we already know quadrilaterals are polygons that have four sides. We know that prefix quad means four. So we're going to kind of look today at some different examples of quadrilaterals. So we're going to start with a quick review of things that you should know from last week. The first word we're going to look at is the word sides, and we know that sides refers to those flat surfaces on the outsides of a shape. We know that a vertex is the place where two sides meet, like that corner right there, and more than one vertex are called vertices. And we also know that angles is that space between lines, and we're typically looking inside the figure to see those angles. We also learned about how there's different types of angles. The one we're going to focus on today is right angles. And remember, right angles are those ones that are like the corner of a sheet of paper or like an L. If you put your arms one straight up and one straight out, that would make a right angle, or you could use your hand and you can make a right angle like that. So we're going to focus on right angles during our lesson today. This next vocabulary slide is some new words. The first word we're going to see here is parallel lines. Parallel lines talks about lines that, if you were imagine a line like this, a true line in the math sense, you can see how there's arrows up on both ends, just like a number line, and it goes on forever. So if we have a line that goes on forever right here, and we have another line that goes on forever right here, no matter how far they go, they would never touch each other, they would never cross, they would never intersect. Those lines are called parallel lines. Now we have to know that word. I do want to throw one other set of words out there because you might see these words, especially in ALEX. Sometimes you'll see the word intersect. Intersect means two lines that cross each other. So if I have a line here and I draw another line like this to make like an X, those lines intersect or cross. And one more word that you might see, if I have a line here and I make another line like this, kind of like a T, but I could turn it in any direction. But if I have a second line that makes a right angle when they intersect each other, those lines would be called perpendicular. You don't have to know those words, but you might see those words in third grade or for sure in fourth grade. So I want you to know what they mean if you see them. But we do have to know that parallel means lines that go like this and never touch each other. They could also go up and down. They could be slanted, as long as they would never touch each other. So let's check out this slide. There's two lines there. Do you think those lines are parallel? Think to yourself. If you said yes, they're parallel, you're correct. Those are parallel because no matter how far they go, they would never touch each other. How about this pair of lines? We have one kind of like this and one up here like this. Do you think those are parallel? If you said no, you're correct, because even though they're not touching yet, what would happen if they kept on going? Eventually they would intersect, which means they are not parallel lines. And how about this pair? If you said they are parallel, you're correct again. So those lines, again, even though they go up and down, even if they kept going and going and going, they're like railroad tracks, they would never touch each other. Okay? Now that we understand what that word parallel means, we're going to look now at some different types of quadrilaterals and the special attributes or properties that those different quadrilaterals have. So the first one we'll look at is a rectangle. You probably are familiar with rectangles. A rectangle is a quadrilateral, which means it has four sides. It also means it has four angles and four vertices. Other special things about a rectangle is that it has four right angles. So if you look inside that rectangle, you can see that every one of those angles look the same, and they all have that right angle like we talked about earlier. You'll also notice in a rectangle it has two pairs of parallel sides. Now remember when we talk about parallel sides, if we only have one side, is it parallel? It's not, it's just a side, right? We have to have a second side to be able to be parallel. Now that we have a top and a bottom, these sides could be parallel. So it's a pair, just like a pair of shoes, right? If you just have one shoe, it doesn't do a lot by itself. You have to have two of them to have a pair. And parallel lines are the same, you have to have a pair. So in a rectangle, we can see the top and bottom lines are parallel. And we can see the sides, the two sides are parallel as well. So in this shape, this rectangle, we have two pairs of parallel sides. The next quadrilateral we're going to look at is a square. Again, I bet you've seen a square before and you probably know this term. Now let's talk about these attributes. A square has four sides again, but there's one important difference. Now in a square, we don't just have four sides, we have four equal sides. That means every one of the sides in the square is the same length. Just like in the rectangle, we also have four right angles. So again, every angle looks just like that corner on a sheet of paper. And a square also has two pairs of parallel sides. Just like the rectangle, we have the top and the bottom are parallel, and we have the two sides are parallel. So if you notice, the rectangle and the square are very similar. The only difference that we see between the rectangle and the square is one word. Did you spot it? That one word is the word equal when we describe the sides. In a rectangle, all the sides aren't equal. The top and bottom are equal and the sides are equal, but not all four sides. But in a square, they are. So that's kind of an interesting thing to think about then. Can't we think about a square as a very special kind of rectangle? So just like we have all of these shapes are quadrilaterals, then we have rectangles rather. So we've got quadrilaterals, rectangles are an example, and then squares are a really special example of that. And we'll look at some other ways to think about that a little bit later on. The next type of quadrilateral we're going to think about today is a parallelogram. It's a big fancy word, parallelogram, and you can see right there in its name, it has the word parallel, right? And that's pretty important because the most important thing about a parallelogram is a parallelogram has to have two pairs of parallel sides. That means the top and bottom have to be parallel and the sides have to be parallel, but check out in that picture how they're slanted. Right? So they're slanted, but they're still parallel because they could still go on and on and on and never touch. Now, when we think about that definition, does that definition fit a square? It does, because a square is another example of a parallelogram. And how about a rectangle? A rectangle also fits the description of a square, a rectangle also fits the definition of a parallelogram, which means squares are parallelograms, rectangles are parallelograms, and all of those are quadrilaterals. Now, again, that's kind of a little bit of extra thinking, but I want you to start to recognize those connections a little bit as we go. The next one we're going to talk about today is a rhombus. A rhombus also has four sides, and just like a square, it has that real important word there again. Not just four sides, but four equal sides. And a rhombus also has two pairs of parallel sides, just like the rectangle, just like the square, just like the parallelogram. So maybe you notice some connections here again. So let's go back for a second. When we went from a rectangle to a square, do you remember how there was just one change in that definition? And that one change was that word equal, right? So a rectangle had four sides, but a square had four equal sides. Well, here we have a parallelogram with those four sides and a rhombus with four equal sides. So it's that same difference from from a parallelogram to a rhombus. Now, what's different about a rhombus and a square. So much information we're looking at today, isn't there? So let's look at those two again. So a square was 4 equal sides, 4 right angles, and 2 pairs of parallel sides. What about a rhombus? A rhombus also has 4 equal sides, so that part was the same. It also has 2 pairs of parallel sides. So what's different? Did you spot the difference? If you said that a rhombus does not have 4 right angles, you're absolutely correct. A rhombus doesn't have to have right angles, but everything else is the same as a square. So just like we saw earlier, we've got some connection. Could we call a square a special kind of rhombus? We could, because it has all the same descriptions as a rhombus, but it also has 4 right angles. And the final type of quadrilateral we're going to learn about is a trapezoid. And trapezoids are really, really different than all the other things we've learned about so far. So they still have 4 sides because they're quadrilaterals. But the next thing is very different. The next description says it has 1 pair of parallel sides. All of our other figures had 2 pairs of parallel sides, but a trapezoid only has 1. So let's look at the first trapezoid on the left. When you look at that trapezoid, where are the parallel sides? Let's start by looking at the sides. Are the 2 sides parallel in that first figure? They are parallel. Those 2 sides would never touch, even if they keep going on and on and on and on. How about the bottom side and the top side? Are those sides parallel in that first picture? They're not parallel, because if those lines were to continue somewhere off to the left, that they would end up intersecting with each other, which means they are not parallel lines. How about the trapezoid on the right? Let's check out that trapezoid. How about the top and the bottom of that trapezoid? Are those parallel? Those are parallel lines. And how about the sides? If those 2 lines kept going way at the bottom somewhere, they would end up intersecting, which means they are not parallel sides on the 2 sides. So they also have just 1 pair. So either of those pictures, they look pretty different, but either picture fits the description of a trapezoid with just 1 pair of parallel sides. That's a whole lot of information. I know it's a little bit confusing when you put it all together like that. I know that's a lot of information, so we're going to look at that now in this table format to help you understand a little bit better what we just talked about. So you can see here we listed all the types of quadrilaterals that we just learned about. And then you can see the next column talks about what's special about their sides. And then we have a column that talks about what's special about their angles. And then what's special about their parallel sides. And then finally a picture of what that shape might look like. So a few things I want to point out as you look at this table. So first of all, you can notice here where it says rectangle. And then under there, very little, it says the word square, because remember, squares are actually special kinds of rectangles. Under the word rhombus, we also have the word square real little, because remember, squares are also special types of rhombuses. And below the word parallelogram, you see a lot of words. We have rectangle, we have square, and we have rhombus, because all of those are special forms of parallelograms. So as you look at this whole big table, some important things to notice. One thing that stands out right away is a trapezoid. Remember, a trapezoid is the only quadrilateral with just 1 pair of parallel sides. All the rest have 2 pairs. So that's a pretty big difference. Other things to notice, we have squares and rhombuses or rhombi that are the only 2 figures that have all 4 equal length sides. So that's different about those 2 figures. And then you can also see something special about a square and a rectangle. Those are the only figures that have 4 right angles. So those are some of the things that kind of set those different figures apart. So when you're thinking about what quadrilateral you're looking at or talking about, those are some of the things to think about. One more version I want to show you to help you kind of relate all those different shapes. This looks kind of like a fancy picture at first, but it actually is very meaningful. When you look at this whole picture, all of the shapes in this figure, or this picture rather, are different quadrilaterals. So we have here this big white shape. Think to yourself, do you know the name of that shape? It is a parallelogram because it has two pairs of parallel sides, nothing's equal, and no right angles. That's kind of our most generic type of quadrilateral. Inside there, you're going to see lots of other shapes because all of those figures are examples of those special cases of parallelograms. So one of the figures we see inside there is that pinkish purple kind of color. That's a rectangle. Okay, and the only difference between that and a parallelogram was now we've got those four right angles. So it becomes a special kind of a parallelogram. Over here, this yellow one, now we just have one more special feature. Now we took that parallelogram and we made it so that all the sides were equal. So now we've got a parallelogram, but with four equal sides. And what do we call that? A rhombus would be the name of that shape. Then you can see this orange shape kind of overlaps these other two shapes. And it overlaps them because remember, a square is that really special shape that has the features of a whole lot of different shapes. It has all the features of a parallelogram, it has all the features of a rectangle, and it has all the features of a rhombus. It makes it the most unique of all the shapes because it has four right angles, four equal sides, and two pairs of parallel sides. So every one of the attributes we talked about today is right there in that square, which makes that the most unique of all the shapes. Then we have this poor shape over here all by itself. Think to yourself for a second, do you know why it's by itself? If you remember back up here on this table, this shape was very unique because it has something very different than the others. It has only one pair of parallel sides. So that's why it's kind of by itself over here in this figure, because everything here, the parallelogram in white and all the shapes inside, have two pairs of parallel sides, but that poor trapezoid has just one. All right, we're going to put a little bit of this to practice now and see if you can identify some mystery quadrilaterals when I describe them to you. So if I have a figure that has four sides, you know it's a quadrilateral, and I tell you all the sides are the same length and there's no right angles, what would be that mystery quadrilateral? If you want to pause it to think about it, you can. So four sides, all the same length and no right angles. And if you look up here, or you look up here at the table, hopefully you came up with rhombus as the correct answer to that question. A rhombus has four sides, all sides the same length, and no right angles. Let's try this one. I have four sides, I have four right angles, I have two pairs of parallel sides, my top and bottom are the same length, but all of my sides are not the same length. What am I? And again, if you want to pause to think longer, you can. And hopefully on that one, you came up with a rectangle. A rectangle has four sides. It has four right angles. The top and bottom are parallel, and the two sides are parallel. And then finally, the top and bottom are the same length, but all of the sides are not the same length. What if they were all the same? Then it would be a square, right? All right, last one. I have four sides. I have only one pair of parallel sides. What am I? And again, you can pause it if you want time to think. And hopefully you came up with a trapezoid. Remember here, that's what makes that trapezoid special, is it is the only quadrilateral with just one pair of parallel sides. So that was a fantastic job today, friends. I know that was a lot of information for one lesson. Hopefully some of that sticks with you. If not, there's lots of resources. You can go back and watch this video, and we'll have other things posted throughout the week to practice and keep learning about more and more about quadrilaterals. So excellent job, and I'll see you next time.